Rob Seco Future Farm. Today's innovations, tomorrow's solutions.
Welcome to Future Farm from Rob Seco. I'm your National Agronomy Leader, Todd Claussen. We are here in Waterloo, Nebraska, in far eastern Nebraska today. One of our 36 demonstration sites that we utilize to bring value and use as a proving ground for our system approach of seed and seed-driven crop inputs. So as we approach the end of the 2025 cropping season and crops life, we want to focus on one thing, and that's yield in corn. And now when we think about yield in corn, understand that bushels per acre is simply a math equation. Let me demonstrate what I mean by that. So the math equation, there are basically four components to our math equation. Number one, it's how many rows around the ear. Number two, it's how many kernels per row in length of row. How many of these guys do we have on a per acre basis? And then lastly, how big is that kernel? That kernel size is terribly important at the end, because you've all done it. We average 16 to 18 rows around, 36 to 38 kernels in length, somewhere between 32 and 35,000 ears per acre, at least in this irrigated part of the world. And then what is our common denominator of how many kernels does it take to make a bushel? And what that ends up being is kernel size and kernel weight, not test weight. That's the real focus of today's conversation. When we think about those components, your corn crop's alive approximately 130 days. Okay? So where do the number of rows around, and when does that take place in the corn crop, in the cornfield? About V5, V6, V7, rows around form. What about the kernels in length of row? Kernels in length of row take place about V10 up through VT. Now understand, that's about a 20-day period. Things move fast in the corn world when we're thinking about those reproductive phases. Right? The number of harvestable ears per acre takes place way back in the first 20 to 25 days. What we want to focus on today is how deep is that kernel and how big is that kernel could be, because that component is desperately, critically related to the yield on your farm. So when we think about that depth of kernel, the end of the crop's life is how long can we keep it alive? It's that last 20 to 30 days. When we get to dent, when we get to that first milk line, we end up being about 20 days from black layer. What if we can keep that plant alive longer? Keep that plant alive longer, and the size of the kernel just keeps getting bigger and bigger. More carbohydrate fill that endosperm to give us a larger kernel, and that's what we want to get to. Because kernel bushels per acre, kernels will be anywhere from 80,000 per bushel up through 110, maybe 115,000 kernels that make a bushel. And we have separation in so many ways. We have a situation here that we are the same hybrid, and we have big time separation in the size of the kernel because of the competition on one plant next to the other. This has got the same number of rows around and the same number of kernels in length, which your kernel count has already been in place about the first part of August to the first week of August. But look at the separation in the kernel size there. We also have major separation in differences of hybrids. These are two different hybrids that have the same number of rows around, but we have significant separation and depth of kernel. Remember, that depth of kernel makes a big difference. If we have 90,000 kernels that make a bushel in 250 bushel corn, which is what we're standing in front of today, 90,000 versus 85,000. So if there's 5,000 kernels difference, separation in the ability to make a bushel, that's 13 bushel an acre. In 200 bushel corn, that's about 9 bushel an acre. So the critical factor of that last component of yield, depth of kernel, size of kernel, makes a difference. And when we talk about kernel weight, that's what we mean. We mean empirical weight. That is a scale. This is a kernel. There's the scale, there's the kernel, that's empirical weight. I want a bigger kernel. I want a kernel that has greater weight, greater size, so fewer kernels make a bushel. Every time we speak about kernel weight and kernel size, folks always want to say, oh, you mean test weight. I don't mean test weight. Test weight and kernel weight are two separate situations. Kernel weight is directly related to the end component of yield. Kernel size makes a difference and directly related to yield. If you can look at the size of those kernels, there's a significant difference. So this one will take fewer kernels to make a bushel than this one. Well, this one is greater value in the field because fewer kernels make a bushel, greater bushels that we have. Now kernel weight, test weight, which one of these will have better test weight? The one with the smaller kernel. Why do I say that? Because remember, test weight's volumetric. Test weight is the total weight of a bushel. What that also means is that's 32 dry quarts. So what's the total weight of 32 dry quarts? Number 2, yellow corn, is an average of 56 pounds per bushel. So when I think about kernel size versus kernel weight, I'm going to give you a demonstration between large kernels, kernel size, and small kernels in kernel size. And which one do we want? Okay. When we think about volumetric, these are basically dry quarts. 32 dry quarts make a bushel. So I'm going to put in a big kernel. I'm going to use golf balls. Now I'm going to put in a smaller kernel. I'm going to use marbles. Which one weighs more? You've got better test weight here than you do here, but you have greater kernel size and kernel weight here than you do here. Which one weighs more? Which one has a bigger kernel? Which one will take fewer kernels to make a bushel? You've already got kernel count out there, August 15th. What we want to do is keep it alive as long as we possibly can. There's ways to do that. To get a bigger kernel, on the backside, we want to protect the last 20 to 25 days of the crop's life. We do that in several ways. One, we can have really good prerequisites and very good vegetative growth through the season. But what really matters is that grain fill period, and particularly keeping it alive as long as possible, to keep pounding dry matter into that kernel to extend the endosperm to create a larger, heavier kernel, that fewer kernels make a bushel. We do that at VT with fungicide. We do that at VT with nutritional products, particularly nitrogen and sulfur, that continue to increase chlorophyll, that continue to increase the photosynthetic activity, that will continue to build sugar or carbohydrate that funnel into that kernel. Now, if you want test weight, that's a completely different story because we have different test weights, and when we think about different hybrids, this type of hybrid versus this type of hybrid, what I have in my hand is a large kernel, big endosperm, fewer kernels make a bushel type of a hybrid. Okay, it has a big chewy kernel. You've got huge kernel depth. And then we have a different style of hybrid that has excellent grain quality and a smaller kernel. If we look at the differences in there, we'll have much better test weight with a hybrid like this. One, it's got a smaller kernel. Two, it's got a harder cap or a harder endosperm. Right? What that means is that I can pack more into a given volume. It also has a smoother cap, a smoother surface, relative to this hybrid that has a real rough cap on the end, a real rough surface, creates more friction, doesn't allow it to pack in that given volume of a quart. 32 quarts make a bushel. So big difference between kernel size and test weight. For my value, the kernel size is one of the major 4 components of the math equation to what we call yield, bushels per acre in corn. Thank you for visiting again our future farm site here in Waterloo, Nebraska with Rob Seco. I'm Todd Claussen.